Good afternoon. My name is Jim Hutton, and this afternoon I'm going to introduce you to some of the environmental hazards faced by sailors 30 to 60 years ago. First of all, my apologies for not being there in person as planned. Unfortunately, due to a non-service related health problem, I'm not able to travel. And at the time I recorded this, it wasn't known if I would be able to even be there via Microsoft Teams. So without further delay, this is Environmental hazards at sea during the period 1955 to 1990. There were two classes of ships during this period. The River class, which included HMCS Nipigon shown here, and the Traba class. The River class ships were designed in the 50s and powered with steam turbines. The Traba class destroyer escorts were designed in the 60s and were powered by gas turbines. One thing that all of these ships had in common was that they were designed and operated with environmental hazards. The primary reason for this was that there was little known at the time of the risks that these chemicals and products posed to sailors during this period. Chemicals such as carbon tetrachloride, trichloroethylene, polychlorinated biphenyls, as well as unconfined radiation and asbestos could be found throughout these ships. Today, these are all known to be carcinogens and are now labeled and handled appropriately, but that wasn't always the case in these ships. It wasn't until the mid-80s that restrictions and labeling was introduced. Radiation presented a hazard during this area, both from a design perspective and from a poor understanding of the risks to sailors. I'm going to start with the fire control radar that I helped maintain during my early career as a technician. This radar was used to track aircraft using a parabolic dish to focus the radar beam. It operated in the X-band area of the spectrum and transmitted at a frequency of 7.2 gigahertz. To give you an appreciation of how precautions changed during this era, I'll share a couple of my experiences. First, in 1972, I attended a Fire Control Trade Group 2 course at Stadacona. For some reason, the curriculum for this course included having the students stand in front of the radar to observe how the mutation of the feed horn changed from scanning to tracking an aircraft. As the class stood in front of the radar looking into the parabolic dish, I recall telling the instructor that my ears were getting warm. My concern was interpreted as a joke. However, I wasn't joking, so I moved to the side to avoid the radiation beam. A few years later, I was selected to study engineering at military college. When I was posted to my first ship as a systems engineer in 1984, I discovered that there was a new appreciation for the dangers posed by the fire control radar. Whenever this radar was flashed up, the upper decks had to be cleared of all personnel. In 12 years, we went from standing a few feet in front of that radar to piping the entire forecastle out of bounds every time the radar was operated. Another radiation safety experience that I had occurred in 1985. I was doing rounds with my chief when I entered Radar 2. I could immediately feel the radiation. When I looked around, I saw the side panels were off of the SPS-12 long-range radar, and a DB fan that was normally used for desmoking the ship was blowing cold air into the cabinet. When I asked what was going on, one of the techs explained that the cooling fan in the radar transmitter had failed, and the officer of the watch had denied their request to take the radar offline for an hour to replace the fan. In response, the techs had rigged an external cooling fan which required the side panels to be removed from the radar transmitter. They thought they were doing the right thing by working around the problem and keeping the radar operational. However, in the process, they were exposing everyone in the compartment to radiation at a frequency of 1.8 gigahertz, which is about the same frequency as your microwave oven. I told them to put the panels back on and convince the officer of the watch to take the radar offline for an hour or so the techs could replace the cooling fan. I now wonder how many of those techs developed cancer as a result of that experience. More importantly, if they did develop a cancer, Did they recognize the connection between their cancer and their exposure on that day? And if they did they submit a claim with VAC? And did they ask for a review when VAC rejected their application? Asbestos. This presented a hazard during this era by design. It was not considered a hazardous product in the 1950s, and therefore it was used extensively throughout the ships built during this period. There were no warning signs like the one shown here, informing sailors of the dangers of disturbing the asbestos-laden lagging that covered the many pipes that ran throughout the ship. Fortunately, much of it was encapsulated by layers of paint over the years, at least the bottoms of the pipes, that is. However, the tops of the pipes were inaccessible to the spray paint. As well, this encapsulation was also compromised in many areas from the many years of unattended abuse during storing evolutions. Also, the joints of the lagging that covered the pipes was often exposed. One example of the paint on the lagging being compromised was the occasional misuse by sailors who unknowingly exposed themselves to this carcinogen. I recall having the top bunk in 12 mess where steam lines ran a couple feet above my head. As evidenced by the many holes in the lagging, it provided a convenient place to shove pens and pencils and to hang your webbing when it was not in use. No one, including myself, thought for a minute that they were exposing themselves to a hazardous material. Another way this partially encapsulated asbestos was sent airborne was when the ship encountered heavy seas. The whole ship would shudder and vibrate, and dust would often filter down from the deckhead, some of which likely contained asbestos. The same thing happened every time the guns and mortars were fired. These asbestos-laden pipes would shake and shudder, dislodging dust from the unsealed joints and compromised lagging. Polychlorinated biphenyls, or PCBs. Although PCBs were banned in 1979, they were contained in the cooling oil of most transformers fitted in ships constructed in the 1950s and 1960s. These transformers occasionally failed and leaked their oil, which needed to be cleaned up before the transformer could be replaced. In the early 70s, that job was assigned to the most junior of sailors. I recall on more than one occasion being sent to the half deck of HMCS Assiniboine to clean up PCB-laden oil from a blown transformer in the fire control radar transmitter cabinet. This was a confined space, so you had to lay on the deck and reach into the bottom of the transmitter cabinet and soak up the oil with paper towel. This often resulted in oil covering your bare arms and work shirt. No protective equipment was used. The oil-soaked paper towels were put into a plastic garbage bag, which was disposed of by poking holes in it and throwing it over the side. In contrast, in 1984, when I returned to the ship, I learned a new process for cleaning PCB spills. The new procedure involved first crash stopping the ventilation and sealing it off by closing the doors to the compartment. Then two people dressed in hazmat suits entered the compartment with special absorbent pads. The PCB-laden oil was then cleaned up and the absorbent pads placed in a plastic bag along with the hazmat suits. Everything was then double bagged. The bags were then isolated and sent ashore for destruction when in home port. Dry chloroethylene. This product was used to remove grease. It was one of the carcinogens that was found in the water at Camp Lejeune. In my trade, we use this product to clean the gear rings of the upper deck visual fire control sites. I know other trades used it more extensively and in closed-door settings with limited ventilation. There were no warning labels on this product at that time. Today, it's appropriately labeled, warning that it can cause cancer and birth defects. Carbon tetrachloride. This was used as a disinfectant and to clean electrical contacts. There were no warning labels on this product at the time, but today's labels warn that it causes cancer and birth defects. Carbon tetrachloride was used throughout the ship, and it was used by most trades, many of which are shown here. As a disinfectant, it was used to sanitize sound-powered headsets, which, depending on the ship's program, could be used on a daily basis. Sound-powered headsets were not like the headsets of today. They were literally sound-powered. They had a horn that you spoke into. Because they were not very efficient, you literally had to shove the horn so close to your mouth that you were literally licking the residue from the carbon tetrachloride cleaning every time you spoke. However, when used to clean electrical contacts, it was much more dangerous. In my trade, we used it on a regular basis to clean electrical contacts on the fire control computer and the fire control radar. The computer stood about 6 feet high and was 5 feet wide. It consisted of 30 drawers, each containing 3 or 4 vacuum tube modules. The planned maintenance routine required each module to be removed and placed on the bench upside down. The contacts on the bottom of each module and those in the drawer were cleaned with carbon tetrachloride. To achieve this, the carbon tetrachloride was poured into a large can and splashed on the contacts using a paintbrush. In the process, you often had the product splashed on your arms. There was no such thing as PPE at that time. After an hour or two of cleaning the contacts, you became intoxicated from the fumes since there was poor ventilation in the space. The intoxication was short-lived once you left the space. However, you often experienced a massive headache just a few hours later. I recall being asked why I didn't report the headaches to sickbay, so they would have been documented. Well, there was a culture at the time of being tough and not complaining. Besides, going to sickbay and disturbing the doc from his evening rum just because you had a headache would have been ill-advised. You didn't go to sickbay unless you couldn't control the bleeding of an injury or a broken limb. That's just how it was in those days. To give you a better understanding of this culture of denial, I'll recall an incident that occurred around 1973 in HMCS Huron. The ship was at a buoy in Bedford Basin. I was a leading seaman at the time and was tasked with bringing the workboat on board. Myself and 2 others moved the boat into position directly under the boat deck and made it ready to be hoisted on board. The davits that held the block and tackle that was used to hoist the boat aboard were welded to the deck. The workboat was slowly raised out of the water, and when it was about 20 feet above the water, the davits gave way and we all went crashing down. The weld securing the davits to the deck broke, causing the davits to fall forward under the weight of the boat. The 3 of us hit the bottom of the boat hard. We all had various injuries, from bruised knees to damaged backs. However, when we got back on board, I recall the officer of the day asking if we were okay and needed to go to sickbay. All 3 of us, almost in unison, replied, "No, I'm good." Yes, each of us limped away and suffered in silence for the next few weeks. Today my back is fine, but what if I had developed arthritis related to the accident? This occurred 50 years ago. How could I possibly convince anyone that the accident actually occurred, let alone that I suffered an injury on that day? Just like the case of cancer, it's unlikely that a doctor could say with any certainty that the arthritis was connected to any particular injury. Yet, if I were to take a polygraph, you would be convinced by the results that the accident indeed happened and I did incur an injury.